All right, here we've got the very beginnings of the section 9.6, which is going to be dealing with polar coordinates. Here is a little fill in the blank of what polar coordinates are. To form the polar coordinate system in the plane, fix a point O called the pole or the origin, and construct from O an initial ray called the polar axis. Then each point P in the plane can be assigned a polar coordinate. Polar coordinates are assigned as kind of like an xy value, but for polar it is r theta, and the r is the distance from the origin or the radius, and the theta is our angle from the x-axis. So it's the directed angle counterclockwise from the polar axis. Let's go ahead and look at a diagram for this so that you know what each part is referred to. So here is, let's say, like my x and y axis, and O for the origin, or the pole, they call it the pole. And so r is the distance from the pole, and theta here is this angle. So then the coordinate, this point, can be represented as a polar coordinate r theta. What we're going to look at now is actually plotting some polar coordinates. When we plot polar coordinates, we plot them on what's called a polar plane. This is a polar plane. And you can see that the axis is circular because r is a radius, so it's always the radius of a circle. So we're going to use this diagram here to plot our points. When we are plotting points, we're actually able to name each polar coordinate in 4 ways, and it all represents the same location. So the first one that we're going to do is 2 3/4 pi. All right, the point that I'm going to look at here, 2 3/4 pi, is going to be located right here. So we go 3/4 pi. So 3/4 pi is located here in quadrant 2. And 2 units out. So I go 2 units. Each one of these circles represents a unit. So this is the point that we're referring to. Now here's how we actually name those points. The first one is 2 3/4. That's the one given to us. So 3 more ways. You also need to use the same positive 2, but also name the one that's coterminal to that. The coterminal angle would be going clockwise and using negative angles. So that would be negative 7/4 pi. Excuse me, negative 5/4 pi. Whoops. Negative 5/4 pi in quadrant 2 there. All right, now 2 other ways that we name it, and we refer to the r value. And what we do is we do the reflection of. Well, a reflection is a negative r value. So if I reflect this point across, then it would be in this quadrant right here. This is not actually the point. The point is still here in this first quadrant, or second quadrant, but the reflection is over here. So the reflection, I would use negative 2 for both of those measures. And then I need to name the location for that. So one of them would be going all the way around to quadrant 4, which would be a positive 7/4 pi. And then I need to do its coterminal as well. The coterminal would be negative 1/4 pi. And so that is how you graph those points. And that's also how you name them in 4 different ways. Again, this is the point here that we are naming. All right. Okay, the next point that we're going to go ahead and graph and identify is negative 3, negative 7/6 pi. So the first thing that we're going to do is I'm going to write down the point that we're going to graph, negative 3 7/6 pi, which means I'm also going to have a negative 3 and another angle, and I'm going to have 3 and 3. So we'll name all of these angles. Let's first find the actual location. I need to go to 7/6 pi. Well, 7/6 pi is located, this is negative 7/6. Yeah, negative 7/6 pi. It is located right here, and it's 3 units out. Okay, this is the negative 7/6 pi, 3 units out. However, since it's negative, I actually need to do the reflection of. So the reflection comes over here to, so this is actually the quadrant 4. So this is actually the point. Okay, now here's how it works for naming. You see here that I went originally to negative 7/6 pi, okay, because this is 0, and we're going in this direction to 7/6 pi. It puts us in quadrant 2. So I need to name its coterminal to that. The coterminal angle to this would be 5/6 pi. So I've named both angles here in quadrant 2. Now what I need to do is name both angles in quadrant 4, and that would be considered the measures that go with the 3 and the 3. So this angle would be going all the way around 11/6 pi, and then back as a negative angle, negative 1/6 pi. The main thing that I think you need to pay close attention to is when you go to write your points, your negative angles or your negative polar coordinates, these should both be coterminal to each other, and your positive ones should both be coterminal to each other. This point that I drew in here right here, it's just a reference. The actual point that I graph is here. So you do not even need to put this little X in here as a reference. But it's basically indicating that these two measures need to be coterminal to each other if you're using negative 3 together. All right, that's how you graph. When we are using these polar coordinates, there are some other things that we will do to them. We can convert them from one to another. And here's how you convert. Coordinate conversion. The polar coordinates r and theta are related to the rectangular coordinates of x, y as follows. So you've got x is equal, and we've done some of this before, but your x is equal to r cosine. Okay, so this is the location, r times cosine, and y is equal to r times sine. Tangent is y over x, so all of these are things that we're familiar with when we were working with trig. And then this is just the equation of a circle, x squared plus y squared. All right, let's go ahead and take a look at example 2. Plot the point given in polar coordinates and find the corresponding rectangular coordinate. All right, I'm going to go ahead and plot this letter A here on this side. Let's draw a little coordinate system here. Do the best that we can. All right, so here's what we need to do. We're going to negative 2/3 pi. Negative 2/3 pi would be in quadrant 3, but since the r value is negative, I'm going to have to reflect it. So this is like a reference to negative 2/3 pi, and if I reflect that, then it's going to be right here. So there's my point. I don't think I got a very good location on that. I don't have my, this is the negative 2/3 pi right here. The reflection of that would be up here. Your coordinates will always have little lines that kind of indicate the 30, the 60, and the 90 angles. All right, now what we need to do is we need to convert them to our coordinate system, our x's and y's. So to find the x, you do this. X would be r cosine of my angle, theta. So that would be negative 3 times the cosine of negative 2/3 pi. So we can just calculate all that. Negative 3 and cosine of negative 2/3 pi is You have to find the cosine of negative 2/3 pi. And that is equal to negative 1/2. So this is equal to 3/2. So the x-coordinate is 3/2. All right, now we find the y. So y is equal to r sine of theta. And r is negative 3. Sine of negative 2/3 pi is negative 3 times, and the sine would be negative root 3 over 2. Multiply those together, it's 3 square root of 3 over 2. So there's our x and our y. So for this one, it's 3/2, comma, 3 square root of 3 over 2. Those would be the exact values. All right, we've got negative 3, comma, negative 1.57. Okay, so this must be a radian measure, and I'm just going to use that. If I want to do this, we need to figure out what the angle is. If I want to plot this. Well, 1.57 is equivalent to pi over 2, and some of those you just might be familiar with all the calculations. If you want to convert it back to a degree to have a better idea, you see you can take this and you can multiply it by 180 over pi, and you'd get 90. Okay, so we know that we're at 90 and as an angle, but it's a negative angle. So this is the reference point. This is the reference point for negative 1.57, but since 3 is negative, we reflect it, and so here's where we're located. Right there. That's the actual point. All right, in order for us to find our x and y, so x would equal r, negative 3, times the cosine of negative 1.57. Well, the cosine at negative 1.57 is negative 3 times negative, so the cosine is 0. Cosine of negative 1.57. All right, so we've got our x to be 0, and now we're going to do our y. Well, y is equal to negative 3 times the sine of 1.57. Negative 1.57. Well, that sine is, so y equals negative 3 times negative 1, which equals 3. So our coordinate xy is 0, 3. And these coordinates, they should match up to where our point is located. The point is located here above at 0, 3. All right, I'm going to go ahead and pause the video here, and in the second video we will finish with the polar coordinates and also with doing more converting and using some equations.